All right, in this video, we're going to talk about 3 by 3 systems of equations. In other words, 3 equations, 3 unknowns. This first example is a little bit of a simpler example. You have 3 equations, you have 3 unknown variables, x, y, and z, but it's what we might see or be here called a triangular form. In other words, the simplest equation can be solved in one step. Then we can just back substitute to find the solutions to the other variables. For example, 3z equals 12. We can easily solve that equation. If 3z equals 12, if we divide by 3, we know that z is just equal to 4. So we've got one of our solutions right out of the way. Then we can move up to the next equation, which is a little bit more difficult than that one. So 5y plus z equals negative 11. But we already know how to substitute. So 5y plus z, which was 4, equals negative 11. So if I subtract 4 from both sides, 5y equals negative 15. So if I divide by 5, y will equal negative 3. And then, since we know y and z now, we can do our first equation to find x. 4x minus 3 times y, which was negative 3, minus 2z equals 5. So 4x plus 9 minus 8 equals 5. 4x plus 1 equals 5. So if I subtract 1 from both sides, 4x equals 4, divide by 4, so x is equal to 1. So the ordered triple answer that you have for this problem is the triple 1, negative 3, 4, x, y, z. That would be the solution to this system of equations. I should be able to check this by going backwards and plugging in the 1, negative 3, and 4 and making true statements with every equation. This one looks a little bit more difficult. You have 3 equations, 3 unknowns, but none of them are more simple than the other. So in this one, we're going to try to use the elimination method. Now, to do that with a system of 3 equations, 3 unknowns, I have to use one equation twice. So what I'm going to do is I'm going to use this first equation twice, and the reason is because the y variable is kind of singular there. It's got a 1 coefficient. It looks like it might be easier to manipulate to use with these other equations. So that's what we're going to do. I'm going to write the 3x minus y plus 2z equal to 13. I'm going to pair that one with the second equation. 5x minus 3y minus z equals to 3. And then I'm going to use the first equation again. 3x minus y plus 2z equal to 13. With the last equation, 4x plus 2y plus 5z equals 30. Now, for this to work, you need to get the same variable to drop out of both sets. So I'm going to try to get the y's to go. So I'm going to multiply the top equation by minus 3. And I'll need to multiply the top equation by 2 on the second set. So that's going to give me negative 9x plus 3y minus 6z equal to negative 39. 5x minus 3y minus z equal to 3, which is going to give us negative 4x, the y's will drop out, minus 7z equal to negative 36. So I'm just going to leave that alone for just the time being. And do the same thing on this other set. So I'll have 6x minus 2y plus 4z equal to 26. Then 4x plus 2y plus 5z equal to 30. So when we combine those equations, the y's will drop out. I have 10x plus 9z equal to 56. So now that I have 2 equations, 2 unknowns, both with the same variables that are unknown, I'm going to put those together in a system. So let's see what I've got here. Negative 4x minus 7z equal to negative 36. 10x plus 9z equal to 56. Now, what I could do, I can tell on this one, I could get the x's to drop out if I multiplied by a number that would give me 20 on top and bottom, negative 20 and positive 20. So I will multiply the second equation by 2, and the top equation by 5. So let's see what we get when I do that. That would give me negative 20x minus 35z equal to 36 times 5, negative 180. And then on bottom, 2 times 10x is 20x plus 18z equal to 112. So negative 35 plus 18, that gives me negative 17z equal to negative 68. If we divide by negative 17, z will equal 4. So we do have one, we extracted one solution. So now to find a second solution, I'm going to use one of my two equations, two unknowns. So how about we just pick this first one here? Negative 4x minus 7 times 4 equals negative 36. So negative 4x minus 28 equals negative 36. If I add 28 to both sides, negative 4x will equal negative 8. So x will equal positive 2. So now I've extracted two solutions. I have the x and I have the z. So to find the y, I'm going to have to go back and substitute into one of the original equations. So I'm going to just take the top equation there. 3x, so 3 times 2, minus y, plus 2 times z, so that's 2 times 4, equals 13. So 6 minus y plus 8 equals 13. That gives me 14 minus y equal to 13. So y would equal 1 in that equation. So my solution, my ordered triple, would be the ordered triple x, y, z. So 2, 1, and 4. Now remember, that should work for all equations and make them all true. So let's go through and check to make sure that they work. We know they work in the top one, but let's check the bottom. 5 times 2 is 10. 10 minus 3 would be 7. 7 minus 4 would be 3, so that one checks. Also, on 4x, would be 4 times 2, 8. Plus 2 would be 10. 5 times 4 is 20, so 10 plus 20 does make 30. That solution makes every equation true. So when you're solving a system of 3 equations, 3 unknowns, it is a little bit of a steppy process. So make sure you keep your stuff organized and watch your signs, because you can really mess it up just by making one little small mistake. Here's an application problem that's going to deal with a 3x3 system. A sparkling water distributor wants to make up 300 gallons of sparkling water to sell for $6 per gallon. She wishes to mix 3 grades of water selling for $9, $3, and $4.50 per gallon, respectively. She must use twice as much of the $4.50 water as of the $3 water. How many gallons of each should she use? Okay, so what we're going to do, first we're going to assign some variables here. I'm going to let x equal the number of gallons of the $9 water. Y can be the number of gallons of the $3 water. And Z is going to be the number of gallons of the water that's $4.50. Okay, so we know that we've got to make up 300 gallons. So the number of gallons of X, Y, and Z has got to all add up to be 300. So there's one equation. X plus Y plus Z we know has to equal 300 gallons total. Now she wishes to she's wanting to sell hers for $6 per gallon. She wants to mix the three grades of water selling at $9, $3, and $4.50 per gallon respectively, and she wants to sell hers for $6 a gallon. So that equation would be $9 times X, the number of gallons, plus 3 times Y plus 4.5 or 450 Z would equal her 300 gallons times $6, which we know is what, 1,800. So the total amount for that would be $1,800 in the total amount of money. Now the last clue that we were given says she must use twice as much of the 450 as of the $3 water. So twice as much of the 450 water as the $3 water. So what we're saying there is the amount of the $3 water, Y, it's got to be twice as much of the 450. It's got to equal to 2 times the amount of Z. So Y is going to equal 2 times Z. Twice as much of the 450 water as of the $3 water. That is not right. She must use twice as much of the 450 water as the $3 water. So actually, the number of gallons of the 450 is going to have to be 2 times the 3. The amount of the 450 is twice of the 3. So that's it. Z equals 2Y. That's the better equation right there. She must use twice as much of the 450. So the amount of 450 has got to be 2 times that of the 3. So that is the equation. Z equals 2Y. Okay, so now we have our 3 equations and our 3 unknowns all put together. We got to solve the system. So with the fact that they gave us Z equal to 2Y, that's a pretty easy equation. I could use that to just substitute. So I'm just going to back substitute. Instead of putting Z in my equations, I'm going to use 2Y. So in the first equation, I will have X plus Y. Instead of Z, I'm going to put plus 2Y equal to 300. And so we know that's going to be X plus 3Y equal to 300. All right. In the second equation, you have 9X plus 3Y plus 450. And we know that Z is equal to 2Y equal to 1,800. So that's going to give me the equation of 9X. Let's see, that would be 9 plus 3, 12Y. Okay? So we have a system of 2 equations, 2 unknowns. Let me write that in a different color so you can kind of see what's going on here. X plus 3Y equal to 300. 9X plus 12Y equal to 1,800. So since I want to get the x's to drop out, I'm going to multiply by -9 on top. So that gives me -9x minus 27y equal to -2,700. 9x plus 12y equals 1,800. The 9x's drop out. I'm left with -15y equal to -900, it looks like. So y equals $60. So we're going to have use 60 gallons of the $3 water. So 60 is going to be the amount for y. Now we know that z is equal to 2 times y. So if we know that, z equals 2 times y. So 2 times 60 would be 120 gallons of the 450 water. And that helps us hold true in our system here that we had twice as much of the 450 as we do the $3. So that makes that all true. But so we know the amount of x plus y plus z equals 300. So now that we know y and z, we could say, okay, x plus 60 plus 120 equals 300, which we know x is going to be x plus 180 equals 300. And subtract 180 from both sides, so x will equal 120 as well. So 120 gallons are needed of the $9 water as well. A little bit confusing to get your equations set up, but this was your system of equations. You were able to use substitution to kind of help you get your equations